Very good morning. This is another lecture on Introduction to Quantum Computing. In previous lecture, we have discussed what and why quantum computing, features of quantum computing, and types of quantum computing. As we know, quantum computing refers to a computational technology that uses the principle of quantum mechanics to process, store, and manipulate large amount of data and perform complex calculation for conventional computing system and supercomputer. Now here we will discuss the advantages and disadvantages of quantum computing, history of quantum computing, government agencies for quantum computing in India. Now, first we start with the advantages and uses of quantum computing. The first advantage is fast calculations. Quantum computing is a new and exciting field in computer science. Quantum computers can solve certain problems much more efficiently than classical computer. One of their advantages is that they are not constrained by the factoring limit, meaning they can factor large integers instantaneously, and this can be used in cryptography and provide a solution to long standing RSA problem. For example, SOR algorithm for factorization. You can see, for example, using classical computer, we do the factoring of 2048-bit number. Then it will take around 100 years. But using SOR algorithm, the quantum computers will take few seconds to minute to factorizing this number. Another advantage is storing and retrieving data. A quantum computer can store, retrieve, and process a large amount of information in a fraction of time needed by the digital computer. It is possibly because of quantum computers deal with qubits instead of bits. There is another advantage of storing information in quantum computer as qubits. It is that information cannot be altered or hacked by the anybody. This is because a quantum computer uses the phenomena of superposition to interrelate the two states, which make it impossible for an unauthorized third party to know exactly how the states are related. The another advantage, they can solve complex problems. A quantum computer is faster and more powerful technology than any other conventional computer. In classical computer, to solve complex problem, it is necessary to break it into many different parts, and it will require more time than is necessary. By using quantum computers, complex problems can be solved instantaneously and in few steps. Quantum computers can solve complicated problems because of the idea of superposition and entanglement. The another advantage is new technologies. A quantum computer is a new technology with various features that are yet to explore in its development. Quantum computers have the potential to make the world significantly more efficient, secure, and energy efficient than ever before. The another advantage is the high privacy. A quantum computer is highly confidential and secure. It uses the phenomena of superposition to form the supercomputer that make hacking impossible. They are also ideal for storing and managing passwords and cryptographic keys without fear of being hacked or intercepted by the hackers. They can have the advantages in medicine creation or healthcare, as quantum computers can create new medicines and vaccines to fight disease. They can help to cure disease that have so far been unable to be cured. Quantum computing make it possible for medical researchers to run simultaneously on millions of different factors with a high level of accuracy. They can find disease and figure out how to make medicines using these computers. Scientists can diagnose and test for different kinds of disease in lab. The another advantage is use in radar making. In future, quantum computers will be used to monitor and control the functionality of a large number of radar devices that are currently installed in all modern airplanes. Radar missiles can also be made with the help of quantum computing. This technique can be used to make radar weapons more accurate. The another advantage is used in artificial intelligence. Recent development in quantum physics shows that quantum computers will play a crucial role in future artificial intelligence development. Quantum computer system can provide the basic for solving some of the most challenging problems in artificial intelligence. We can take the advantage of quantum computing in machine learning. Using machine learning technique, it is a good way to use quantum computing for image recognition, speech processing, computational linguistics, and pattern recognition. Another advantage is interaction of individual particles. A quantum computer can also simulate a system that have some form of interaction of individual particles. These computers could help in the development of new materials, chemicals, and drugs in future. Another advantage is in internet security. Quantum computers are ideal for storing and managing password and cryptographic key without fear of being hacked or intercepted by hackers. Quantum computers will help to create new methods of internet security, which is one of the main purpose of quantum computing. Another advantage is in deep learning. Deep learning is a type of machine learning, that aim to mimic the way neurons interact in the brain. This is very powerful form of computing and quantum computer can be used for this computing. Another advantage in computational chemistry. Quantum computers will also find new ways to solve problem in computational chemistry. This is because they can help us to model the chemical interactions with electrons and atoms in computer model. Once these interactions are known, it is easier to study their properties and possibilities. Another advantage in finance. Some studies say that it is the short term, the finance industry stand to gain the most form of quantum computers. The first benefit of quantum computing for finance is that it let us figure out stock market outcomes that were too random and too many to figure out before. Quantum computers will be able to handle the fact that investors want more accurate risk assignment for different possible scenarios. We can have the advantage in climate forecasting. Quantum computing might also be able to tell what the weather will be like. This could help a lot of industries that depends on the weather, such as transportation, food production, and more. In USA, the wealth has a direct or indirect effect on near 30% of the GDP. In India, it is 18%. This is also be able to predict the weather with which people will get more time to get ready for disaster. Now we come to the disadvantages of quantum computing. Quantum computing is a complicated and controversial technology that has potential to revolutionize computing in future. Besides the advantages, there are some disadvantages of quantum computing. First one is the algorithm creation. It has to write a new algorithms for each type of computation. They need special algorithms to do tasks in their environment. A classical computer has a processor, memory, and software. There is no such thing in quantum computing till now. Another disadvantage is the low temperature needed. Quantum computers requires extreme low temperature that are hard to keep. It cannot be isolated from its environment because it has to interact with the environment. If it interacts with the environment, it will lose its quantum nature. This is why quantum computers need to be operate at incredibly low temperature. They need to be at a temperature of minus 460 Fahrenheit, very low temperature. Now, another advantage is that quantum computers are not open for public use. as of now. They are not available commercially. Even if they are, no one would be able to use them because there is no software or algorithms to run on them. They cannot be used by public because they cost too much. Also, these types of computers make a lot of mistakes because they are still being developed. When there are 10 qubits, quantum computers work fine. But when there are more qubits, like 70 qubits, their accuracy is not correct. Another disadvantage is in internet security. The internet is the main way by which we can send and receive information. Quantum computers will take over the security of the internet, and this could destroy the world. Scientists think that if a quantum computer will build in the best way, it will break the security of the whole internet. This is because all the codes on the internet can be broken by this computer. The another disadvantage is heating problem, as quantum computers are very fragile and they break easily because of their environment. The smallest amount of heat can destroy the computer, and this is an issue. When the information is saved and retrieved, it needs to be very accurate. If there is any change in the information, it needs to be rewritten because it would not work with the same software. Another disadvantage is difficult to build. It is difficult to build a quantum computer because the researchers need to find a way to get the qubit accurate. Quantum computers cannot be run on the traditional computers. Software and algorithms programs are needed to work with these computers. There is a lot of work that need to be done for the computer to run correctly. The another disadvantage is low precision. Quantum computers have a low level of precision. Scientists have to create their own qubits, which is difficult. They are hard to find and even harder to control. Also, they have to be stable because if they are not stable, the computer will constantly shut down. The another disadvantage is high maintenance. Quantum computers are very expensive to maintain. They have to monitor constantly because they can easily break. The another disadvantage is decoherency. Decoherency is the process by which information of quantum system is altered by the system's interaction with its environment. The coherence time means how long a qubit maintain the superposition. It may be around 10 to 100 millisecond coherence time. There are many causes of decoherency: thermal noise, electromagnetic radiation, imperfect isolation of qubits. So after this, we are coming to the history of quantum computing. In 1982, history of quantum computing starts with Richard Feynman lecture on the potential advantage of computing with quantum system. Feynman discussed his conjecture in the Conference on the Physics of Computation at MIT. In the same year, physicist Paul Benifo also discussed how computers are capable of working under the established law of quantum mechanics. In the year of 1985, David Desha published the idea of universal quantum computer. He proposed what became known as the quantum Turing machine, a theoretical machine that modeled the mathematics behind quantum computation using quantum gates, a set of operation that permits multi-state computer. In 1994, after 9 years, Peter Shor presents an algorithm that can efficiently find the factors of large number. This algorithm referred to as source algorithm. Source algorithm incorporated both entanglement and superposition to determine the prime factors of an large integer. The efficiency of this algorithm was brilliant and in fact managed to break RSA public key crypto system. In 1996, Lovegrover present algorithm for quantum computers that would be more efficient for searching database. It is referred to now as Grover's search algorithm. In the same year, Lloyd proposed a quantum algorithm which can simulate quantum mechanical system. In the year 1998, researchers from MIT, the Los Alamos National Laboratory, and US Berkeley, Neil Grassenfield, Isaac Chung, and Mark Kobenik respectively create the world's first functioning quantum computer. The computer itself was a 2-qubit quantum computer that utilized nuclear magnetic resonance to manipulate the spin of particle in the atomic nuclei of the fluid they used. In 1999, D-Wave System Company was founded by George Rose. In 2000, Eddie Fari at MIT develops idea for adiabatic quantum computing. A 4-qubit quantum computers was created by National Institute of Standards and Technology. Here in 2001, IBM and Stanford University published the first implementation of source algorithm factoring 15 into its prime factors on a 7-qubit processor. In 2010, D-Wave Company released its first commercial quantum computer. In 2016, IBM makes quantum computing available on IBM Cloud. In 2019, Google claims the achievement of quantum supremacy. It is a term coined by John Preskill in 2012 to describe when quantum systems could perform tasks surpassing those in the classical world. In 2020, D-Wave Company announced a new version of their quantum annealer, which has 5,000 qubits and is optimized for solving large-scale optimization problems. Quantum annealing is a special case of quantum adiabatic computer used for combinational optimization problem. For example, finding the minimum of a function. In 2023, IBM and Google joined forces invest around $150 million in quantum computing research at US and Japanese university. In 2024, Microsoft and Quantium achieved 12 logical qubits in September 2024, then 24 logical qubits with atom computing by November 2024. In the same year, D-Wave Advantage 2 offers 25,000 times speed boost for material science problems over its predecessors. Also, Google proposed a computer with 105 qubits in December 2024 and demonstrated error suppression and performing a benchmark task in 5 minutes versus supercomputer that take around 10 is to the power 25 years. That is super fast. And in 2025, in the current year, Microsoft presented its topological qubit chip, that is Majorana 1. In the same year, India's first 25 qubit superconducting computer launched in April under National Quantum Mission. India's Apsache launches Quantum AI curriculum and Amravati Quantum Valley roadmap in June 2025. This is Andhra Pradesh State Council for Higher Education. Now we come to the quantum computing in India. Indian government has signed off around 6,000 crore rupees or $730 million and plan to make the nation a quantum computing and communications power by year of 2031. The National Quantum Mission aims to deliver intermediate scale quantum computers with 50 to 1000 qubits within 8 years. The mission aimed to make India one of the leading nations in the development of quantum technologies and applications. Here I am just giving the name of seven best quantum computing research institute in India. The first one is Raman Research Institute. This institute awarded a grant from Ministry of Electronics and Information Technology. Their targeted areas are quantum communication, quantum sensing, quantum interaction. In April 2023, they have demonstrated a secure satellite based quantum communication in collaboration with ISRO. Another institute is International Institute of Information Technology, IIIT Hyderabad. They carries out the research on the role of quantum science in computation, information processing, quantum thermodynamics. Another institute is Harish Chandra Research Institute. This is located in Prayagraj. They actively involved in research surrounding quantum algorithms, quantum communication, quantum cryptography, and the theory of entanglement. The another institute is Tata Institute of Fundamental Research, TIFR, Mumbai. The primary objective of this laboratory is to develop techniques for stabilizing quantum states against decoherency. Another institute is Indian Institute of Science Education and Research, ISR Mohali. They works in the area of experimental quantum computing, entanglement characterization, decoherency mitigation, and experimental implementation of quantum algorithms. The sixth institute is Indian Institute of Science, Bangalore. They focuses on superconducting qubits device, single photon source and detectors for quantum communication, integrated photonics, quantum networks, and quantum sensors. Not last, but the seventh institute is the Indian Institute of Technology, IIT Madras. They focus on areas including quantum key distribution, quantum sensor, quantum computing, post quantum cryptography, quantum error communication, and quantum algorithm. Along with this, IIT Jodhpur, IIT Bombay, IIT Delhi also making significant contribution in quantum research. I'm showing you the list of government organization to provide funding for quantum computing in India. These are non-profit agency that perform research or provide funding for quantum field. That is Ministry of Electronics and Information Technology, Government of India, Department of Science and Technology, Ministry of Science and Technology, Government of India, and Indian Space Research Organization, ISRO, that is Space Agency of India. This is the end of this lecture. In the next lecture, we will discuss about the introduction of quantum mechanics. Till then, thank you.